welcome to my YouTube channel. Give me 3 minutes. I will discuss the whole two-dimensional dynamical system and the stability and the different types of equilibrium point for this system. Let's take the system x dot equal to ax plus by and y dot equal to cx plus dy. So this system can be written as x dot equal to a plus x, where x is this and a is the coefficient matrix a, b, c, d. And if we find the in equilibrium point x star y star, and if we find Jacobian matrix at this equilibrium point b star, then it will look like a11, a12, a21, a22, where this a11 is del f del x, this is f function of xy, this is function g of xy, function of xy. So a11 del f del x, a12 is del f del y, and similarly a21 is del g del x and a22 is del g del y. So then you will get this Jacobian matrix, and on the basis of the sign of the eigenvalues of this Jacobian matrix, we can say what type of characteristic of this equilibrium point. Let us discuss. For this 2 cross 2 matrix, lambda 1 lambda 2 are eigenvalues. So if both lambda 1 and lambda 2 real and negative, then the equilibrium point will be instead is stable node. Okay? Node, stable node. If lambda 1 and lambda 2 are of opposite sign, that is one is positive and another one is negative, then E star will be saddle. If lambda 1, lambda 2 are complex conjugate like alpha plus minus I beta, where alpha is negative, that is complex conjugate with negative real parts, then this E star will be stable spiral. Okay? And if lambda 1, lambda 2 with positive real parts, then unstable spiral. Okay? And most importantly, if lambda 1 and lambda 2 purely imaginary, that is plus minus I beta, alpha is 0, so real part is 0, purely imaginary, then E star will be center. Okay? Stable node will look like this. If this is stable node, then the solution trajectory approaches toward like this. If this equilibrium is saddle, then it will look like one axis stable and other axis to other axis unstable. So trajectories will from one side approaches to this equilibrium point and from other side it is away from this equilibrium point. So this is saddle. Stable node, so this is unstable spiral. This is equilibrium point. So from this unstable spiral, so this will happen when complex with positive real parts. And if this is equilibrium point, and if the solution trajectory is converging to this equilibrium point look like this, so this will stable spiral, and the center is look like is closed orbit. So I have discussed all the types of equilibrium point. So on the basis of sign of eigenvalues of the Jacobian matrix, evaluated the equilibrium point, which are discussing the nature. If both the eigenvalues real and negative, then the equilibrium point is stable node. If both real but opposite sign, then it will become saddle point. And if complex conjugate with negative real parts, then the equilibrium point will be stable spiral. If complex conjugate but the real parts is positive, then the equilibrium point will be unstable spiral. And the eigenvalues, if the eigenvalues are purely imaginary, then the equilibrium point will be center. So that's it for today. So if you like it, please subscribe my channel, share with your friends. I will discuss briefly the characteristic of two-dimensional dynamical system and the types of equilibrium point through eigenvalue, eigenvector in the next lecture. So it will be very beneficial for the students who are investigating paid or play dynamics or dynamical system. So if you like it, please subscribe my channel and share with your friends. Thank you very much.